Yes, so Srikal students, let's talk about chapter 1, matter around us. Let's talk about matter. Will include both CBSE and ICSE in this. So, first of all, students, what is matter? Well, there are two perspectives to understand matter. One is our old view. If we especially talk about this country, the old view, we used to, call matter as Panch Tattva. In Punjabi also they say Tat. In Hindi also it's Tattva. So there the matter was all about air, water, then you can say space, or you can say sky, then earth, and anyone remember the fifth one? Air, water, sky, earth, and fire, right? So Jal, Vayu, Agni, Akash, Ag, Pani. So these were the, this was the way the matter was visualized. And I think this was a broader way in which the matter was realized, because now if some student asks whether fire is a matter or not, whether sky is a matter or not, so there's a confusion in the students, but the old view included fire and space or sky also as matter. We all know now earth, then water, then air, anything we can touch, anything which occupies space, that is a modern definition of matter, is matter. But that old view also used to include sky and fire also, and that, I think that's more broader view. So now, if you talk about, nowadays science, which has not completely advanced in all the dimensions, but whatever we have the understanding, based upon this, the matter is classified into two types nowadays. So one is we call that the first group, in which we say liquid, solids, and gases. Well, this classification is based upon their physical properties, right? When I say physical properties, students, from physical properties, what do I mean? How they look like. Physical property, iron. If I touch iron, it's very strong, right? But it's very strong from outside. I'm not talking about atomic structure or अंदरों कितना दवा, how it is from inside. No. Then I talk about wood. When I say wood, physical property, I say okay, it's not very strong as iron. Wood floats in water, iron sinks in water, density of iron is more, density of wood is less. So all these things, these are physical properties. I can touch with the hand, I can feel, I can visualize with my brain. So that's all about physical properties. Okay, liquid, solids, and gases. Right. Then now we have plasma state of matter also, and then Bose-Einstein state also. Okay, but normally we talk about these three states. Fine. And then the second group in which we classify matter is like based upon chemical properties, right, students? When I talk about chemical properties means, can any student tell what is the meaning of chemical property? Any student? Okay, so chemical property is about their chemical reaction, you know their chemistry, their we talk about their valency electrons, all that, the chemical properties. So it's all about chemistry and chemical reactions. So when we talk about chemical properties, then the matter is, we define the entire matter into elements, then compounds, and anyone else, and mixtures, right? So we'll discuss them one by one in detail. You know, what are elements? See, students, when we talk about elements, very, very basic thing. Like we have some elements like iron, we have aluminium, we have more than 100 elements, maybe 108 elements. Most of them we can feel, we can touch, we can experience, but there's some elements, they occur only in between the chemical reactions for a certain amount of time. So more than 90-95 elements, yes, we know, we can touch. We know all the 108, but iron, aluminum, these are the elements we use on day-to-day life. Then gold, Au, silver, Ag, zinc, platinum, so like so many are there. Okay. So then copper. So there's so many elements are there. But then what is the difference between elements and compounds? Now, students, I observe so many compounds around me. For example, a lot of plastic is there in our home. Plastic, right? Plastic pipes are there, plastic containers are there, plastic tubs are there. Now, this is not an element. This is everything. Everything is made up of elements, all the compounds, mixtures, but it's not an element. Plastic. I'll tell you how. Then let's talk about bell metal. you know Bell metal, we go to temples, we do tan, so they are made up of this is like a compound. And then the gold you wear, that is also not pure. It is actually gold plus, any student, the gold your mother wears.
Copper.
Oh, beautiful. Gold plus copper. More is the copper, less will be the cost. Then we say 24 carat, 23 carat, 20 carat. That means the amount of copper is varying. And so they are perfectly, you know, like uh, gold is there, copper and iron. Okay, fine. Then can you give me more examples of compounds around you, students? What
Water.
about Sanjay? What?
Water.
Water, beautiful. Yeah. Then carbon monoxide, carbon dioxide. Okay, all these are you can say compounds. Uh,
Methane.
Pardon me.
Methane.
What? What? Punu? Please repeat. Water. Then we can talk about so many things. So many kinds of plastics, rubber. What about glass? You use a lot of glass. you know so anyone knows which is the element in the glass, main element? Silicon. Okay, so these are the compounds. Now, what is the basic difference between these elements? Then mixtures. Okay, now when I talk about mixtures, so then it can be sand and maybe salt mixture. Okay, then it can be you know mixtures. They can be separated. The constituents can be separated with your hand or by physical methods. They are mixtures, right? uh, what is the difference between elements and compounds, students? You see, if I talk about iron, let's say I have 1 gram of iron, right? Interestingly, students, we know what is the basic constituent of elements, means which is the fundamental block which make the elements. Tell me, students, anybody, what is the fundamental? Like, if you make a house, the brick is the fundamental block. All the house is made up of bricks. So many shapes, so many bungalows you can make, houses, small houses, mud houses. But ultimately, it's a brick or the block, which is making your house. So, what is making your matter, your entire compounds or elements, is the atom.
Atoms.
Correct. Atom. Okay. It is an atom. Fine. And then there were scientists. They sometimes postulated, like Dalton, that atom is indestructible. It cannot be further broken into subparticles. But then he was proven wrong, because then we had protons and anyone else? Protons. Can anyone tell more?
Neutrons.
Neutrons, electrons, you know. So protons and neutrons together, they are known as nucleons, right? They are in the nucleus of the element. So there were a lot of research. how they found out this electrons, protons, neutrons, the neutrinos. Okay, fine. So atom is the basic building block of the element. Students, interestingly, in all the elements, interestingly, you will find the atoms of only iron, nothing else. This is the main difference between elements and compounds. You will find only iron, 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 Fe, Fe, Fe atoms, nothing else. You will not find even a single atom of any other element. Single. One element, only iron elements. Okay, only single element. This is element. Okay, but when you talk about compound, like one girl told water, H2O. Now H2O means how many elements, Monroes, are there in water? How many elements are there? One is hydrogen, two atoms of hydrogen, and one atom of oxygen. Now
Oxygen.
hydrogen and oxygen are also elements. Okay, they are gases. They are existing in gaseous states, but they are also elements. Okay, so this is compound. If you talk about carbon dioxide, okay, so in this also carbon is there in every molecule of carbon dioxide. Now students, in case of compounds, the basic constituent or the fundamental block is not atom. It is molecules made up of atoms of different elements. Like the basic building block of carbon dioxide gas is CO2. That means one carbon atom somehow, that we will explain later on, is bonded to two oxygen atoms, and this becomes the basic building block of carbon dioxide. So wherever you find, suppose you have carbon dioxide, in your entire atmosphere. So everywhere, if you take a sample of carbon dioxide, you will find same structure. Carbon, one molecule of carbon will be carbon bonded to two atoms of oxygen. This is the basic difference between elements and compounds, students. Elements are made up of their own atoms only, but compounds are made up of atoms of different elements. There may be compounds which have two elements, three elements, four elements, five elements, maybe more than that elements, atoms also. Am I right? This is the basic difference between elements and compounds. Let's go further. Okay. Now comes physical nature of matter. So I told you, when I talk about physical nature, so it's like how they behave, with the eyes, how we feel them, with the hands, how we feel them, physical properties. Okay, nothing to do with their chemical properties, right? Okay, so now for example, you have a paper. So what are the physical property of a paper? इसको अपन फाड़ सकते हैं. Paper can be torn with the hands. It's a physical property. It's very light in weight. मतलब it's okay. पेपर है, बस ठीक है, फाड़ दो इसको, बुक बन जाएगी इसकी. That's physical nature. Chemical nature, उसको आग लगाओ तो जल जाएगा. It will convert into ashes. They are chemical properties. किसका बना हुआ है? Chemical. Okay, fine. Physical nature of matter. So when we talk about physical nature of matter, you know, we find two things when we talk about physical nature of matter. Number one, every matter is made up of certain particles, which, and these particles, they differ in shape. These small particles, they differ in size, and they differ in their nature from other type of matter. What is the meaning of this? Simply, students, is meaning whether the matter is element, whether it is compound, or whether it is a mixture, whether it is a solid, whether it is a liquid or a gas. Solid like iron, aluminium, zinc, platinum, uranium, and liquids like water, you know, then maybe honey,
carbon,
then what? Wax is also solid, but if you melt it, it becomes liquid. Honey, then liquids. Come on, liquefied, liquefied petroleum gas (LPG) normally is in gaseous state, now in your cylinder, but under high pressure it becomes liquefied petroleum gas also. Then, so many examples of liquids, right? Okay, milk. Okay, and then gases like you have carbon dioxide, you have carbon monoxide, you have oxygen gas, you have nitrogen gas, you have hydrogen gas, so many gases. You have so many gases. Okay. So whether they are compounds, they are, elements, mixtures, solids, liquid, gases, they are all made up of either atoms. These are the particles he's talking about. Basic certain particles. He said, na, the when we discuss the physical nature of matter, we understand that they are all made up of individual particles. And when we talk about these particles, very very small in size, very very small. We can't even imagine, and we cannot see them with naked eye. We need to have microscope. So these are atoms or molecules in case of atoms, in case of students, elements, and molecules in case of compounds. These are the small particles he's referring to. Now, the atom
compound,
iron will be entirely different of atoms of copper. This is what he means when he says in shape, in size, in nature, they'll be different. Its nature will be different. Size will be different. Why size will be different? You know that now you have studied atoms and molecules because if more number of protons and neutrons are there in the nucleus of a atom of an element, it will be bigger in size. If you talk about hydrogen, it has only one proton, not even a single neutron in the protium, isotope of hydrogen. So it will be very small, smallest atom possibly. Smallest atom will belong to hydrogen. As you go more and more heavy metals like uranium, plutonium, the size will be more. Shape will also be different, like that. Okay. So when you talk about shape, it possibly means how these atoms are arranged. This is another thing, very interesting. In diamond, you see, students, in diamond and simple carbon, like it's all carbon, but only the because of the shape, diamond is very hard. But if you talk about our tawa, in which we make rotis, so that tawa is also carbon. But you can break the tawa with your small simple stone. If you bang the tawa on the floor, it will break. But you cannot bang the diamond and it will break. You can put a very heavy load on diamond, it will not break. So shape, size, they're all different. Okay. Number two, what we observe from physical nature, these particles are very small or tiny. These particles are very small or tiny. Then I've already discussed that very, very small in size, beyond our imagination. The physical nature of matter. Okay. Then comes the characteristics, means characteristics like characteristics of a person. Somebody is very happy, somebody wants to inflict injury to others, somebody wants to inflict happiness to others. Some people are very saintly. They all want to forgive, they all want to be happy and let everyone else be happy. And some other people are having different nature. So let's like the characteristics of human beings. We have characteristics of particles also. What are these characteristics? And from the particles, what he means, students? From the particles, he means atoms are, come on, atoms,
Molecules.
molecules. Characteristics of particles of matter. Entire matter. Entire universe, students, is made up of matter. Entire. Okay, fine. Uh, but then it's beyond my imagination. What kind of atoms? Fire, if we consider fire as an element or fire as a matter, and sky or maybe space as a matter, whether space is a matter, whether fire is a matter, whether sunlight is a matter, that's beyond my imagination also. And if it is so, how is there particles? No, but we are able to understand, view, and digest the concept of how are the particles of this liquid, solid, and gases. So that's why हमारी जो क्लासिफिकेशन यहीं तक सीमित है. ये भी कल को साइंस आप में से कोई और रिसर्च करेगा और अंडरस्टैंड करेगा, so he'll go up to what was the panch tattva, fire and sky. Also he'll possibly find out how these matters are there. किसी ने कोशिश की, लाइक जे थॉमसन, डेल्टन, देन बोहर, नील बोहर, अदर पीपल, उन्होंने कोशिश की, एक्सपेरिमेंट्स किए, तो पता लगा कि भी वो न्यूट्रॉन कैसे हैं, चैडविक, रदरफोर्ड, प्रोटॉन्स कैसे हैं, इलेक्ट्रॉन्स कैसे हैं, कैसे मूव कर रहे हैं, ऑर्बिट्स कैसे हैं. तो ये सारे क्यूरियोसिटी थी बंदे के मन में. क्यूरियोसिटी से एक्सपेरिमेंट्स हुए, एक्सपेरिमेंट से रिजल्ट्स आए, रिजल्ट से बुक्स बनी, बुक से आपको पढ़ाया जा रहा है. बट ये पढ़ाने का मतलब सिर्फ ये नहीं है कि जो पढ़ाया जा रहा है वही तक सीमित है. बहुत कुछ और है. गो आउट, उसको स्टडी करो और उसको सोचो, इमेजिन करो. बट सो कुछ इंपॉर्टेंट कैरेक्टरिस्टिक्स ऑफ particles of matter are as follows. First characteristic: particles of matter have space between them. ये जो particles हैं इनके बीच में space है. Space मतलब जगह है इनके बीच में. Particles may be arranged like this. Particles, like maybe atom, they may be arranged like this. So this is the space between them. And students, very interesting thing. Like we have iron. This is iron. These are the atoms of iron. And tell you one thing, very interesting things, student. People were not very happy with the iron, though iron is very, very important for the upliftment of any civilization. But iron had a drawback. What? जंग लग जाता था. आयरन इज करोसिव, जंग लग गया. देन ऐसा नहीं है कि साइंस का कोई फायदा नहीं है फायदा. इंजीनियर्स केम इनटू पिक्चर. देन पीपल हु स्टडी द माइक्रोस्कोपिक नेचर ऑफ मैटर, दे केम इनटू पिक्चर. दे डिड रिसर्च. व्हाट दे डिड, इन्होंने जो जगह है ना बच्चों इनके बीच में, इसको बोलते हैं इंटरस्टिशियल साइट्स. इंटरस्टिशियल साइट्स, चाहे इनको इंटरस्टिशियल साइट्स कह लो, चाहे आप इनको इंटरमॉलिक्यूलर इंटर एटॉमिक स्पेस कह लो. अगर ये मॉलिक्यूल्स है इंटर एटॉमिक स्पेस, अगर एटम्स है इंटर एटॉमिक स्पेस. तो बंदे ने क्या किया, बंदे ने आयरन के साथ डोपिंग कर दी. किसकी? वेनेडियम. ये आप सब जानते हैं. देन क्रोमियम. देन सबसे इंपॉर्टेंट कार्बन. कार्बन के जो एटम्स हैं उनका साइज आयरन के एटम से छोटा है. वो आपको बाद में मालूम, मैं बताऊंगा क्यों छोटा है, क्योंकि इनका एटॉमिक नंबर आयरन से कम है. तो आयरन के एटम छोटे छोटे यहाँ पर उन्होंने इंसर्ट कर दिए. सी दैट ब्यूटीफुल थिंग, वेरी इंटरेस्टिंग. ये सारे आयरन के एटम्स थे. आपको पता है आयरन एक एटम है और सारी एक एलिमेंट है, और एलिमेंट में सारे एटम्स सेम सेम होते हैं, उसमें कोई और नहीं होता. अब क्या हो गया, जब ये इसमें कार्बन के इंटरस्टिशियल साइट्स पर छोटे छोटे एटम्स इंसर्ट हो गए, कार्बन के एटम्स का साइज छोटा था, उसके बीच में आराम से फिक्स हो गए. फिर वेनेडियम इसके बीच में डाला गया. आई डोंट नो वेनेडियम किस तरीके से इसमें एडजस्ट हुआ. क्रोमियम, मॉलिब्डेनम, मॉलिब्डेनम, मुझे पूरे इसके स्पेलिंग नहीं आते. कार्बन, मॉलिब्डेनम, क्रोमियम, वेनेडियम, इसके साथ डोप किया गया. मतलब किसी तरीके से केमिकल प्रोसेसेस हैं कि इनके एटम्स को इनके बीच में इंसर्ट किया गया, और वो बिल्कुल फैशन एक बड़ी सिमेट्री से एडजस्ट हो गए. यही आयरन क्या बन गया स्टूडेंट्स, जिसके बर्तनों में आप खाना खाते हो, स्टील. एंड यू सी दैट सबसे बड़ी प्रॉब्लम अपने सिविलाइजेशन की रिमूव हो गई. इसको कहते हैं रिसर्च. स्टील, आपके हाथ में कड़ा स्टील का है, आपके बर्तन स्टील के हैं, स्टील का फर्नीचर है. आप देखो स्टील को आप 10 साल पानी में रख दो, कोई जंग नहीं लगेगा, वैसे का वैसा. कितना इंटरेस्टिंग चीज है. ऐसा क्या हुआ, ये डोपिंग करने से, ये एटम्स के बीच में डालने से क्या हुआ कि जंग लगना बंद हो गया. उन्होंने स्टडी किया कि जंग लगता कैसे है. उसके लिए ऑक्सीजन चाहिए, एयर चाहिए और मॉइस्चर चाहिए. तो एयर और मॉइस्चर से जंग लगता कैसे था? ये जो कार्ब ऑक्साइड्स फॉर्म होते थे आयरन के, Fe2O3, FeO, ये ऑक्साइड्स बनने बंद हो गए, ये स्टील में कन्वर्ट हो गया। वंडरफुल। सो इस चीज़ से हो सकता है कुछ बच्चे केमिस्ट्री में, इसलिए केमिस्ट्री इंपॉर्टेंट है, इसलिए फिजिक्स इंपॉर्टेंट है, इसलिए मैथ्स भी इसमें है। तो साइंस इज़ वेरी इंटरेस्टिंग। सो ये बहुत बढ़िया काम हुआ कि आयरन से स्टील बन गया। अब जहाज स्टील के बनने शुरू हो गए। I basically, students, steel में 95 to 96% स्टील आयरन ही है। सारे प्रॉपर्टीज आयरन के हैं। बाकी जो 4% है उसमें 2 to 3% कार्बन, और बाकी जो 1 to 1.5% है उसमें मोलिब्डेनम, क्रोमियम, वेनेडियम मिक्स कर दिया गया। ठीक है, और मिक्स भी ऐसे नहीं कि आप हाथ से कार्बन के पार्टिकल्स को निकाल सकते हैं। यू कैन नॉट टेक इट आउट। एक बार स्टील बन गया, बन गया। दोबारा स्टील से आयरन नहीं बना सकते। इट्स इरिवर्सिबल प्रोसेस। अगर आपके हाथ में कप है और आपने कप को नीचे गिरा कर तोड़ दिया, इट्स इरिवर्सिबल। मोस्ट ऑफ द प्रोसेसेस जो इस वर्ल्ड में है, दे आर इरिवर्सिबल। बट कुछ है लाइक पानी, पानी से भाप, भाप से फिर पानी। कुछ रिवर्सिबल प्रोसेसेस भी हैं, फिर भी 100% रिवर्सिबल नहीं है, कुछ ना कुछ चीज़ लॉस्ट होती है उनमें। फाइन। सो ये बात की मैंने स्पेस की, कि पार्टिकल्स के बीच में स्पेस है। फाइन। आपको अच्छी लगी एक्सप्लेनेशन स्टूडेंट्स? नंबर,
Yes, sir.
वेरी इंटरेस्टिंग। फिर कहते हैं पार्टिकल्स ऑफ मैटर आर इन स्टेट ऑफ कंटिन्यूस मूवमेंट। उनकी मूवमेंट है। ठीक है, इन इंजीनियरिंग, या कल को आप अगर एटॉमिक की स्टडी करो तो उसको बोलते हैं लैटिस वाइब्रेशन। लैटिस वाइब्रेशन, सारे पार्टिकल्स वाइब्रेट कर रहे हैं। मान लो ये पार्टिकल्स हैं, हाँ, ये पार्टिकल्स हैं, ये एटम्स हैं, मान लो किसी भी एक पर्टिकुलर एलिमेंट के। सो ये इनकी मेन पोजीशन है, ये अपनी मेन पोजीशन के ऊपर ऊपर नीचे वाइब्रेट करते रहते हैं। दे वाइब्रेटिंग। एंड स्टूडेंट्स, दिस इज द वाइब्रेशन आज मैं आपको बता रहा हूं, क्योंकि ये वाइब्रेट कर रहे हैं। इसी वाइब्रेशन के कारण आपने पढ़ा था ना कि सॉलिड्स में जो साउंड है उसकी स्पीड लिक्विड और गैसेस से, एनी स्टूडेंट,
ज्यादा होती है।
ज्यादा।
Fast होती है.
दिस इज द रीजन। मेटल्स, खास तौर पे जो मेटल्स हैं, आई टेल यू मेटल्स क्या हैं, जिनको अगर टच करो तो सोनोरस साउंड आती है, स्ट्रांग है। आयरन, एल्यूमिनियम, क्रोमियम, जिंक, दे आर ऑल मेटल्स। गोल्ड, कॉपर, यू नो प्लेटिनम, दे आर ऑल मेटल। सो इनके सारे एटम्स वाइब्रेट करते रहते हैं, और वाइब्रेट करने से साउंड क्या है? प्रोपिगेशन ऑफ डिस्टर्बेंस। सो अब ऑलरेडी ये डिस्टर्ब्ड है, ऑलरेडी ये एक इनकी फ्रीक्वेंसी है जिस पर ये वाइब्रेट करते रहते हैं, और ये फ्रीक्वेंसी पर वाइब्रेट करने के कारण साउंड के प्रोपिगेशन इजी हो जाता है। सो 2, 3, 4 गुना ज़्यादा साउंड की स्पीड सॉलिड्स में बढ़ जाती है। वैसे अगर 420 मीटर पर सेकेंड है, तो ये यहाँ पर 2, 2, 3, 4, 4, 5, 5, 6 हज़ार मीटर पर सेकेंड हो जाएगी साउंड की स्पीड। दिस इज द रीजन। ये मूवमेंट में है। नंबर 3। ठीक है, ओके। नंबर 3, particles of matter have tendency to diffuse। इनमें डिफ्यूज होने की टेंडेंसी है। डिफ्यूज ही हुआ तो आयरन स्टील में कन्वर्ट हो गया। इसको प्रोसेस को कहते हैं स्टूडेंट्स डिफ्यूजन। हमने क्या किया? हमने स्टील में वेनेडियम, क्रोमियम, कार्बन और मोलिब्डेनम के पार्टिकल्स को क्या कर दिया बच्चों? क्या कर दिया? हमने
Like diffuse.
कर दिया।
Diffuse.
डिफ्यूज मतलब वो वापस नहीं आ सकते फिर। सो इनमें, इन पार्टिकल्स में डिफ्यूज होने की टेंडेंसी है। राइट नाउ, ये मैंने आपको एक्सप्लेन कर दिया कि इंटरस्टिशियल साइट्स में हाउ द पार्टिकल्स, स्मॉलर पार्टिकल्स ऑफ डिफरेंट elements can get adjusted in a very correct fashion pattern in the particles of other. And fourth, particles of matter attract each other. They have forces of attraction, like you have attraction, like human beings also have attraction between them. Can you measure that attraction? Can you measure the attraction between human beings, Sargun? We have a universal law of gravitation We can measure the attraction between any two bodies, right? This is m1 mass and m2 mass, right? So force of attraction will be how much? Any student? Between any two bodies, if the distance between their centers is given, fast, what is the force of attraction?
Big G,
Yes.
M mass, big mass, and then small mass divided by distance between them.
नॉट डिस्टेंस बिटवीन देम, आर स्केयर. पहले भी आपने फल्गुन 20-30 डेज पहले आपने जो बोला था, आपने बोला डिस्टेंस बिटवीन देम, आई मैंने तभी आपको रोका था. स्क्वायर ऑफ डिस्टेंस, आर स्क्वायर इनवर्स स्क्वायर लॉ. So we can measure
Okay, sir.
the force between them. But can you measure the force of attraction between you? Students में भी force of attraction होती है. Can you measure that? You cannot measure. That is qualitative. That is qualitative. ठीक है, but in science we only talk about quantitative quantitative things. Okay, so this is like this force of attraction between them. Am I right? So वैसे intermolecular force of attraction भी है. मतलब क्या हुआ? मतलब ये हुआ कि उनके जो एटम्स हैं वो आपस में अट्रैक्ट कर रहे हैं, राइट? उनके एटम्स आपस में, मॉलिक्यूल्स आपस में अट्रैक्ट कर रहे हैं, और बड़ी स्ट्रॉन्ग फोर्सेस हैं. कईयों में कम स्ट्रॉन्ग. अगर बहुत स्ट्रॉन्ग फोर्सेस है, NaCl नमक बन गया, बहुत कम है गैसेस बन गई. विश यू ऑल द बेस्ट स्टूडेंट्स. आई फिनिश द लेक्चर. Don't forget to share the lecture with your friends and subscribe our channel Learn CBSE. This is a complete name. So get into research and say no to your unnecessary homework and unnecessary work. Go and explore the deep concepts, deep mysteries of nature. I wish you all the best. Have a nice time.